My name is Shanttel, as Hannah just said, and I am currently a data engineer at Sage. But my career has sort of moved through all the data science and data functions. I started in university as a computer scientist, then I got a job teaching data science, then I joined Sage as a machine learning engineer, and now I'm a data engineer, which means I focus a little bit further, closer in the a bit more earlier in the data science cycle, but I'm still overlooking all of AI and I'm still coding our AI systems today for our products department. So that's a little bit about me. In this session, we are going to be looking at the data science lifecycle. But we're only going to focus on the section around collection all the way to around visualization and analysis, because I think I can spend 5 hours talking about every single section of it, but I think we don't have that much time today. So let's get into it. What is data science? As we've heard from Morgan and Shabiha, data science is like a mix. I see it as data being the salad bowl, right? And within my salad, I have knowledge of the subject area. So this is your context. What is the data situated in? Also programming, because as they were saying, we've got to a stage where we have so much data and so many complex problems that we need a bit more computational resources to actually get into the data and what it's saying and what we can do with it. So programming is a big part of our AI journey and data science journey, but also a little bit of maths and statistics, because though we have the data and though we have the resources to compute it, we need to make sure it's saying what it's saying. And so we employ maths and specifically the statistics branch of maths to understand exactly what the data is saying and how we can apply it into real life. And our data salad is what is used to make informed decisions, predicting trends, and also improving efficiency, just as Morgan was saying. So in my role, I take my data salad and bowl and I help our organization, which is Sage, to make decisions and also predict trends. So we have decisions such as, should we have this product on this month or not? Or predicting trends as in, this product is getting really popular, should we push this in terms of marketing? Or also improving efficiency. What if we find that one section of our product is not really that helpful to our consumers? So should we just remove it? That kind of thing, data science can tell us, and I work in that section to do all of that. It was also mentioned by Morgan about the different subsets of data science, because as you work in this industry, you're going to hear these words kind of almost used interchangeably, but there is a difference between it. You can think of my white space of my presentation as data science. And within data science, we have artificial intelligence. Within artificial intelligence, we have machine learning and deep learning. So AI is used to basically describe everything, and that's what it is. And machine learning is a subset of AI, just like Morgan said. And a lot of the work that you do as a professional will probably sit within machine learning, because those things are a little bit small. I say smaller, I'm still talking about like a large amount of data. So take that with a grain of salt. But with machine learning is where mostly your statistics lives, your trends lives, where you're predicting all these things. So if you get a job as a data scientist, you're most likely going to live in the machine learning area, but you may also get to live in the deep learning area, which is a subset of it all. And it's where we get our really, really complex systems like ChatGPT and the like, that lives in deep learning. So that's the difference between the words. But like I said, people use them interchangeably, but now you know the difference, which is great. Also, by the way, if you want to put comments in the chat, that's absolutely fine. I love a good chit chat, as you can tell. So comments are absolutely great. If you just like the shade of blue, if you've heard of something before, things like that, and then questions go in the Q&A. Amazing. So where is data science? In the Mentimeter that you gave before, I could see that you know where Mentimeter is. You know where data science lives. Data science is in, I would say, pretty much every industry. I wouldn't say it's in every corner of the earth. I think that's a bit too much, but it's definitely in every industry. You guys gave examples before about like healthcare, finance, social media, also aviation, retail. I work currently in, well, Sage does accounting and like HR products, which is very corporate-y and stuff like that. But I've been in organizations where, you're playing games, they use data science. Education, I use data science in there as well. So It's very, very pervasive in our society, and it's here to stay. That's pretty much the message of this slide. So I've given a quick rundown only because you kind of heard about it before with Morgan. So I assume you guys are experts in it. Well, here's my bread and butter of my job, the data science lifecycle. I use this all the time. This is pretty much my job in a wheel. And this is what all of data science kind of looks through. I would say specifically like machine learning, but you can definitely apply this to all of data science. So first things first, we can start at the top. Right here, you can follow my pink mouse. And at the top, we always start by framing the solution or the problem. What are we actually trying to achieve? This needs to be very clear because this informs what we do in the next stages. So we really spend a lot of time, I say me and my team, or you and your team, can spend a long time just defining the problem. Because what is the problem? Why are we doing this? You know, do we have to? That's a good question. Do you have to? And these are where ethics also play a role in it as well. Do you have to do this? Will this help anything? And if we do have to do this, what kind of solution can we start with? Where do we get our ideas from? You know, what is the end goal that we want to produce? So we spend quite a lot of time on this section. And I'd also work with our ethicists and our governance colleagues here at Sage to really make sure that when we're framing the problem, it does make sense and it's necessary and it's compliant as well. So ethics is in every single step that we do. And I do think it should always be there. The question should always be questioned and answered. After you've kind of got what you're doing, the little problem statement, you know, you've got maybe we're going to try this, or we want to end up with this kind of end product. We now start looking at collecting data. This is where I mostly sit now in my role, in terms of collection and processing data. And this is a big, big chunk because we still have ethical questions here. Where are we getting the data from? What kind of form does the data come in? How long can we keep the data? Can we transform the data? Is it saying what we want it to say? Do we need to pay for the data? Do we have access to this data? Things like that. It's really a big part of your entire journey because before you can get to training models, you need data to train models. And if you don't have the data, you're not going to have a model to train. So collecting data and what kind of data you can and will collect is very, very important. Next, you have to process that data because data is literally information. If it's information about anything, it's data. It can be videos, voice notes. It can also be rows and columns in like an Excel spreadsheet. It could be so many different things. So can I use that data in my model? That's where you start processing it. So also thinking about like, is the data even clean? Does it have missing parts? Is it just 2 data points when I need to commit a model that needs like 3,000 data points? Things like that. So you've collected your data. Is it ready for modeling? This is where you start processing it. But you've collected your data, you've processed it, it's ready to go into whatever model you think you're going to use, or it's ready to like be on your big programming screen with a black background. And before you can start modeling, you need to know what the data is actually saying. Because a lot of the time, you collect data thinking, yes, for example, I'm going to investigate the effect of area. Yes, the effect of area on favorite colors. For example, I'm literally just thinking about this, okay? This is freestyle. So the effect of area on favorite colors, you've collected it, and then you analyzed it. Yep, you got to this bottom of the cycle, and you realize that actually, favorite color is not determined by area. It actually has no bearing at all. You would never have known that if you hadn't analyzed it first to see what the data is saying. So that's why we have to analyze our data before we even put it into any sort of model to see what is the current real life situation looking like, before we start predicting things because of it, or making statements and making judgments and decisions because of it. What is it actually saying first? So you've analyzed your data, you've realized that actually area has no bearing on, on what do you call it, on favorite color. So then what do you do? Any comments about what do you do now? Now that you've seen that, it has no bearing on it, what would you say that you would do next? We're in the analyze data section. You can put it in the comments below. Let's say that you want me in my job, you put your glasses on. You've come to your computer, you've opened it up, VS Code, amazing. And then you click the button that says run it. It runs and it's like, actually, area is nothing. What do you do now? A, panic. Because that's also fine. You're allowed to panic. Like, you're allowed to. No one's going to say don't panic. But are there any ideas of what you might do next? You know, we could panic. That's also path A. One thing you could do is just stop there and just end the research project. But what we happen is we go further back in the life cycle actually and rethink our problem solution and problem statement. Because it's a cycle. You could go forwards and backwards. So we go back to our solution and problem and think, if it's not area, then what is it? And that's where we change it again and go next to the data collection. Like, okay, maybe we don't focus on area data. Why don't we look at, let's look at height data. Maybe the height of a person determines their favorite color. These are just hypotheses that we are looking at and investigating to see if they're true. So we've gone through it again, gone through and analyzed our data and realized that height does make a difference, because we've done some also clever statistics and find that height makes a difference. But which height determines what favorite color, that's when we give it to a model. That's when we give it to AI to start determining those relationships, but also predicting those relationships. So after you've done that, there are several statistical ways to evaluate your model to see if, number one, is it true to the data you gave it? Did it literally just make it up? Is it given random results? Because it can do that sometimes. And also, is it actually just a good model for the data you have? There are many, many evaluation methods, but we need to do that before we get it into deployment. And deployment is a word that low-key I learned on the job because I had never really learned about it. I thought once you're finished your work, it's on your computer and people just huddle around your computer and just look at it. But no, we need to put these things into real life applications. In the same way that your TikTok recommendation is on your TikTok app, it started on someone else's computer first. And then they had to figure out how to embed it into the TikTok application for you to use in person. So that's the data science life cycle. I'm going through it constantly and all the time. But for this session, we're just going to focus on the second bottom half of our life cycle, about collecting data, processing it, analyzing it, and maybe some model generation and things like that. Any questions, let me know. And if I'm going too fast, also let me know. So everybody put your hats on, and I will need some participation for this part. Hello, data detectives. Welcome to the boardroom. You've been called upon to solve a perplexing mystery at the gallery of wonderful Shanttel. You know, I have this gallery where I have many artifacts of me. And recently they've been vanishing without a trace. I don't know where they went. My security systems have been down, and so are the visitor logbooks. They've been compromised. I don't know what happened, but I've lost my artifacts. And we as a collective only have data science on our side. So we're gonna have to solve this mystery using a little bit of data science skills. And I think we can do it. Give me a reaction if you think we can do it. Come on, let's really get into it. Let's really, really bring this to life. That's right. I feel you, because I think we can. We have skills, including data science, and we're going to do it. So these are the examples of art that was stolen, artistic. And I want them back, okay? So the first thing we're going to do is we're going to start. So we've kind of basically made our problem statement in that slide, if you know what I mean. So we're just going to skip right next to the different sources of data, because we're going to collect data now. There's different types of data, and this is important for how we analyze it. You can see how everything kind of knocks on in effect. So there's different types of data that we can collect. The first is structured data. Structured versus unstructured is essentially, is it fixed and predefined, or is it kind of more complex to analyze? So when we talk about structured data, we mean databases, spreadsheets, you know, on Excel, when you have A1 and D11, you know, you can find it easily, it's nicely and organized. That's structured data. But you also have unstructured data. And to be honest, a lot of the data that we analyze and put into models, all that kind of thing, are usually kind of unstructured. Think of images and videos. If a computer only understands binary, which is just ones and zeros, how do we get it to understand a photo? You see what I mean? Like, how do we translate that? I mean, there are ways to do it, but we need to see like, what are we collecting first, and how can we translate it into computer legible data? So it's more complex, but it's not impossible, and it does not deter us. No, because we need to get those artifacts back. So, oh, I clicked too early. Other types of data formats is that you can get your structured and unstructured data, but within that, we also need to get in a bit more, like, more intricate. So we have different other types of data formats within your structure. So you can have structured, numerical, structured time series, and things like that. So we have numerical data, which is like your straight numbers. It can be whole numbers. It can be with decimal points. That's no problem. And these are like sales figures. How many products did you sell in a month? Or temperature readings. What was the temperature yesterday? Just that number is your numerical data. We also have categorical data, which is data that is grouped. So you can have product categories like furniture, technology, bedding. Yeah. But you also have other examples such as like gender and sex. So male, female, intersex, all those different identities can also be categorical, because it's defining groups of things rather than a number of something. But other ones you may not have heard of is time series data. So whenever you see a graph, yeah, and it's like number of things over time, and it's just like really got lots of different points, that's usually time series. And time series is very good because you can see a trend of something over time. So that could be like stock prices. Have you ever seen like a stock graph and it's just lines going up and down? It's because they have data for every single minute or every single second. And so they plot that and it gives you a nice, smooth visual. So that's that. But also weather data. If you plot the temperature over like every minute for 3 days, you get a nice smooth line, don't you? So that's also time series data. And lastly, spatial data. That's something people never really realize that we can still analyze is spatial data, like maps. Because if you think about it, maps are 2D on like an X and a Y axis. Well, Y is up, so Y and an X axis. And we can point, the tree is here, the path is a sigmoid curve going that way. And so we can analyze spatial data as well. So given that information, what kind of data, in the chat, please, get ready with it, would you collect to solve my mystery? Because we're still thinking about that. I still want my pictures back. What kind of data would you collect? So you can describe it in terms of like the actual data you collect, like what number of people came in a day. Oh, I just gave you one. But it can also be like the structured data or unstructured, because it's like CCTV video. Just give me a couple. Image data, amazing. That is exactly the kind of thing we would use, because who did it? Someone take a picture of them. So great, that's a great suggestion. I also said visitor logs, like who's come through to the museum and at what time. And we know when the theft happened, because I turned around and my face wasn't there anymore. So we can also look through those as well. Interview data, we can give that. I do like a little interview, just like so what kind of a great time did you have today? And they're like, I had a great time. So we can also look through them as well. Some people they don't give good vibes. But yes, we can collect that kind of data. And we can also look at, so CCTV, that's a big data source. Yep, see, I agree with you, Mosa. CCTV is a big data source. Surveillance footage is used quite a lot in data science. Visitor logs, like I said, who's come through? When did they come? When did they leave? Things like that. Social media activity, that is data you can collect. There's a technique in data science called scraping, where you go to a website and sort of take information from that website and put it in like a nice table or something for yourself. So I can go through and look at when did people post on my hashtag, who liked certain posts, things like that. These are all data, isn't it? Employee records. What if it's someone on the inside? I doubt it. But what if it's someone on the inside? That is also data that I can use. Now I've collected my data. I'm looking at my CCTV videos. I'm looking at my visitor logs, and there are two different types of data. So how am I going to compare a video to my spreadsheet of people coming in and out without like looking one place and the other place and one place and the other place, because that's a long thing to do for like over 3 weeks of data. This is why we give it to the computers to do it ourselves, because we don't personally have that computing resource to complete that ourselves. But before we can compare it like that, we need to prepare the data for comparison and things like that. And that's where data cleaning, transformation, integration, data reduction, and enrichment comes in. I spend a lot of my time cleaning data or preparing data for analysis and modeling, because this is one of the most important steps in my opinion. When you have data from the real world, it's not perfect. The whole world is not perfect. People don't fill in the time that they come in, or the video skipped 3 seconds. So it's not perfect. So we have to deal with duplicated data, missing values. Some things are just incorrect. We also have problems such as, let's say we have a column that is categorical. So let's say there's category 1, 2, and 3. Some person might write 1, the number, another person writes 1, the word. And now my computer's like, those are 2 different categories. Because that's what computers do. That is just how they do it. So you really have to make sure that you're going through and normalizing it. That's what we call normalizing the data, so that it's all the same one. And it's, if it's categorical variables, that they're all the same term. Sometimes it'll be really picky and it would see, let's say it was the favorite colors thing, capital P for pink and lowercase p for pink, 2 different categories. Thank you, computer. Thank you very much. So this is when I go through and make sure everything is in the same place. Fun fact, if you want to put image, or I think image data, into like a database, what you can do is pixel coordinates. So you convert your picture into like coordinates, and they say that the HG, like the RGB colors for each pixel, don't you? Well, you do. And so you just take those color sort of readings and put it into your table as like at the A1 pixel, the RGB colors are this, and that. So that's one way we can transform an image into just numbers and use that to compare. But again, it takes time, because you just have to, and that's just the job, So that's the kind of thing. But also things like, I want to bring your attention to here, data reduction. If I had a lot of information about group 1 and only 7 cases about group 2, it's very hard to compare like 1,000 versus 7. You're not really getting a full picture. So how do we then make group 1 smaller, but still preserving what the information was for when it was 1,000, or group 2 bigger, but not inventing things that doesn't exist in the 7 people sample? So there's a lot of statistics going on there, which is why you spend a lot of time on it, because you need to figure out what methods do you need to use, are they appropriate, and is it ready for analysis? So I've taken my CCTV data, my visitor logs, and I've put them all in one big database, ready for analysis. And I'd like you to have your little fingers ready for preparing this data for me. This is my visitors log. I don't have just me. Actually, it is just me. The ancient Egypt is just me in an Egyptian set. But John Doe says it was a great exhibit. Now, looking at my visitor logs here, how would you prepare it? Like, what things do you see are a little bit wrong that my computer would have a horrible time trying to analyze it? You can put it in the comments of what things are just not quite right about this data before I can even give it to a computer. You can look at things like the visitor ID, the names, the entry times, comments even. Big number 1, Hannah, names are missing. The names are missing. If I asked my computer model to analyze by name, it would not know. It's not sorted properly. That's also another big thing. In terms of sorting, sometimes computers, if your data type, for example, is not saved as number, it will think that 4 comes before 1 because that's how it came in your data, We have to hold the hand of computers a lot before we get to ChatGPT. Like, there was a lot of humans involved holding its hand, making sure it gets to the right place, because they are literally just machines. And we had to do quite a lot of things. So going back to what Morgan and Shabana was saying about how we're not that close to technology taking over the world just yet. This is one of the reasons why, because we're holding their hands a lot. But also things like, repeated ones. Poor John Doe, his same data has been repeated constantly. So I think like 15 people have been here, but it's just the one guy. It's just the one guy. But my computer might still take that as 15 different people that comes. So when I'm preparing it, I need to remove it. The visitor IDs are inconsistent, and some of them don't have a comment, or the comment doesn't have a name, or things like that. So if I'm now analyzing, someone said, I stole it, ha 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 ha. I don't know who that is because it's not connected to a name or things like that. But also something here in the entry time, there's inconsistency. Some of them have 9 a.m., like John Doe over here, but Jane Smith is just 10. So 24-hour format versus 12-hour format, computer's gonna have a horrible time with it. Another thing we can do is also separate out the date versus the time, because computers don't like that. So again, a lot of hand holding is required in the data prep stage because data does not come perfectly. So let's say I fixed my visitor logbook and it's looking perfect. You're not going to see it because that takes time. And I actually created this, so it took me extra time. But let's just say we've cleaned it. So we're ready to now see what is the actual data saying to us now. And this is where we are going to analyze data. So there are different ways to analyze data, and most often you're going to use pretty much all of them or most of them, or a combination of a lot of them. You know what I mean? So you don't just do, for example, linear regression. You don't just do that and then that's it for your EDA, your analysis. You don't just do that. You kind of do all of them. So we have things like descriptive statistics. So the mean, the mode, the min, the max, all those kind of things. What are those values? You also have things like linear regression, which is looking at, it's not so much correlation, but it is correlation actually. As one thing increases, how much does the other thing increase or decrease? It could be a decrease in correlation. Clustering, what things are more closer together? You can probably group them as in this is one group and is separate and distinct from these things, which are more like one group. Also, time series analysis. Again, like I said, time series is great for trends. We can see if something has seasons. Does it peak every April? Does it peak during the midday and then falls by night, and then peak again during the midday and falls by night? We can see those kind of things with time series. But also, what if I have loads of textual data? So let's say all my reviews, I can use sentiment analysis to see which ones are the positive ones, which ones are the negative ones, but also text mining. And text mining is when you extract the topics of the text. We call it corpus. That's what nearly came out of my mouth. You can extract the topics of the corpus that you're looking at. Are they all talking about the missing art? Scandalous. Or are they all talking about how it was so great and Shanttel was a great host? But that's the kind of thing you could do with your data. So this is the data we have. What kind of things would you be looking to extract from that data? Remember, we have CCTV, visitor logs, social media, employee records. Do you have any idea the type of things we want to extract from it? I can give you one. With the CCTV, I can look for, what kind of things can I look for from a CCTV image? People that walked in and out very quickly, because that's unusual, because you should take an hour and a half at my museum. But any ideas the kind of thing? Let's say, for example, the visitor logs. Is there anything you'd be looking for? Visitors at a different section. Yeah, just lots of just unusual activity, isn't it? And unusual activity has a subset of data science, and we call that anomaly detection. So we can use data science to predict the pattern. What is a normal day, right? What is a normal day? And what is unusual? What is an anomaly within that normal look and atmosphere? That's something that AI can do and is very used, especially in fraud detection. So banks, crime, all that kind of thing. What is a regular use of your account, your bank account? And what's a bit different that maybe we should investigate? Yeah, so that's the kind of thing. We can also look at social media. Forgot to bring that thing up. What is an unusual spike in activity of using my my hashtag, that kind of thing? That's quite unusual, isn't it? So we can also look at that. Fun fact, what is this basketball? I have no idea, sorry. Just everything else I can probably name except this basketball. I don't know what social media that is, but I digress. So once I have my analysis done, it's not good enough for me to just leave it on my coding screen and said, yep, done. Because a lot of the results of these analysis techniques are numbers. Like they're literally just numbers. Like you do your correlation and it will say your correlation is 0.36. And my boss would say, what's that? So we have to take our analysis and make it into a visualization. Can anyone name the types of visualizations on the screen right now? Any of them? And bonus points if you can name like when we use it. That's a bonus because that's an open-ended question. But if you could just name any of the visualization techniques on the screen right now. There's a bar chart. Yes, I love a good bar chart. Never discount a bar chart. There's also the pie chart. Yep. Fun facts about the pie charts. A lot of data scientists hate them. That's just a fun fact. Just because people are not good at seeing how big or small the pie chunks are compared to each other as we think they are. They're not very good at that. So you can really mislead people with pie charts. So that's just a fun fact for you. The thermodetector, yeah, that's a heat map where you can see different like quantities of the space. The line graph, correlation analysis, perfect. Thank you, Benedict. You get extra points for that one. Line graph is used for correlation analysis. Yes, as this goes up and this goes up, what happens? Does the line go up? Does it go down? Does it go wiggly woggly? You know, things like that. A histogram, yeah, it could be, this could be like a histogram or a bar chart because we know they're slightly similar, but histograms like touch each other in terms of like the bars because it's continuous. It's a continuous scale. So it could be, but that's a great example of a bar chart. And then this last one is a word cloud. Sorry, the name escaped me for a second. It's a word cloud, and a word cloud is amazing for not simulating, but like for showing word analysis. So let's say I have looked at all my comments. What is the words that come up most? Very much used a lot of the time in comment reviews or just reviews of places, just to see what is mostly coming up before that. So I can tell in these words, teamwork, innovation, but not so much crisis, which is good. I'm glad crisis is not coming up too much. So that's the kind of thing a heat map can show. So you can use all these types of visualizations to communicate to someone who wasn't there going through the data with you, what you found. It's a quick way to communicate what your findings, but also a way to keep them engaged. So you may find something out. A graph is one of the most perfect ways to communicate what you found, because a lot of people are not experts like you. And so they needed a different way to understand what you've seen. So that's that. Now, guess what we did now? So I actually went digging in my social media post about my museum. And I plotted it on the number of mentions. So that's my x-axis. And on this axis, I have the number of mentions I have versus time. So over time, how does it look? You know, I didn't want to put numbers there because it's quite low, as you can see. Normally, it's quite a low amount, and you get spikes when I have special exhibits, you know, just special exhibits that come up, and it's just like, oh, come to my museum if people come. But this is across all social medias. So I looked at X, formerly Twitter. I nearly said Twitter there. Facebook, Instagram, and Reddit to see how many times are people using my hashtag. And I also ran this data. So I scraped it all of the websites, scraped it, put it into a database, really processed it to see how I can make it, you know, understandable to my computer. And then I graphed it because, again, it was going to give me just a bunch of numbers. Like, I know I'm an engineer, but I'm not a computer. So I need a graph. And I graphed it to see what am I seeing. And just as Mosa also just gleaned right there, there's a huge spike right there. And that is unusual. Although I am very popular, I am not popular for a minimum amount of time. Yes. So that spike is quite unusual to the things I'm doing. And so that's when you start using the context of the thing, you know, the data about it that you know. And I realized that we knew that our artifacts were missing right about here. And then closely behind is a spike in social media. So then I have to dig back into the data. Where is this spike coming from? Who is talking about me so much then? And as you know, as predicted, it was a bunch of people saying, oh my gosh, it's gone. Why is it gone? Who stole it? But there was also an interesting discovery. I found a post actually of someone trying to sell the exact artifacts that I have lost. And that person was arraigned and caught. They were caught because it is not good or legal to steal from my artifact and try and sell them to others. So shout out to that person. They've been busted. And I got my artifacts back. Now, this is obviously an example of how people can use data to get to a solution. This example is definitely into like, we're looking at fraud detection, crime analysis, all that kind of thing. And these kind of things are, well, this specific example is pretty much like the data team in like a police station kind of thing. But there are so many uses of data and AI. The way I use it is looking at, for example, internally. If we want to build a chatbot, that chatbot needs something to talk about. So that's when we start looking at where can we get the data to inform that chatbot, process it, and put it in a way that when we're coding that chatbot, it understands all these things and then produces an answer to people. You have to go through all these steps. And my job is pretty much all of this. Like I said, I started as a machine learning engineer at Sage, and that meant I was looking at mainly just the modeling, the machine learning, that part. And now that I'm moving into data engineering is because, well, kind of, I was too good at my job that the machines can run by themselves. I'm joking. But it's just more like we start looking at where are we getting that data from? And is that data ready to be put into the models? So I'm still working with models. I'm still like a data scientist. I'm still knees deep in statistics, but I'm also looking at what are our data sources? How do we extract from that, wrap it all up and put it to the system that we're currently using, because we're looking at things like security, ethics, governance, all that kind of thing. And that's where we're working with to put that there. So there's many different ways of applying data science. And you as young people can literally find your interest in everything. There's data science in fashion, construction, you know, just fun little silly PowerPoints like this. And if you have any questions, this is the time for it. So that's me done. Thank you very much.
Someone has said, I have seen the report from the World Economic Forum that data analysis are one of the careers that are most vulnerable to be replaced by AI in the future. What are your views on this?
I think it's going to change the job. It's not going to eradicate it. I see the AI panic in the same way as when like color TV came to the scene, where people were like, it's gonna ruin the cinema industry, is going to be wiped out because people have TVs in their homes. But till today, we still have a thriving cinematic industry. So it changes the way we analyze data or the jobs that we do in data analysis. So for example, you're not cleaning all of your data yourself, for example. You may ask AI to do it for you, but you still have that job where you need to analyze it, because things like knowledge or like context, it's a human being that still needs all that kind of thing. Because remember, our AI systems are using past data to predict. Humans can create. And so we still have a role for data analysts in the future. It will be different than what it is now, but it will be there, in my opinion.
Advice on like how you can get into this career, and just maybe like your LinkedIn or anything where people can.
Yeah. My name, Shanttel Kemawor, should come up on LinkedIn. If it isn't, I don't know how to send it out. But Shanttel Kemawor should be able to find it. I fell into data science because I didn't want to be a website developer. Sorry, I didn't want to code that much. And then I got here and I'm coding every day. But it really is just, I think what helped me with the career in data science is that I was able to translate data into to a wide audience. That was the biggest part of it, because I do think that the technical skills you can learn easily. You can definitely do it, but I'm also presenting in front of people. I'm also making sure that the context I know of society and everything, I'm applying to it. So it really is simply passion. It just passion and upskilling. So the more you code, the better your chances are. But if you have passion, you're like 50% there.
Yeah, for anyone who like looks up your LinkedIn, I'm sure that the Teens in AI LinkedIn account will be posting this live stream where they will tag you.
Yes.
So if anyone can't find your LinkedIn, check the Teens in AI page. Um, could you give us a brief explanation of deep learning, please?
Yes. So machine learning is mostly where statistical methods are used. So your linear regression is machine learning, where we're looking at the correlation between X and Y, and does it go up, does it go down? So it's quite straightforward in machine learning. Deep learning is where we have neural nets, right? And nets is where we're looking in more like less the 2D space of X and Y, but like what if X, Y, Z, A, B, C, and all these different dimensions? It becomes more than 3D. You can have like 300 dimensions, which is incomprehensible to the human brain, but a computer understands that. And so when we have all these dimensions, and dimensions are simply factors that affect the result, for example, so the color, the shape, where it is in time, all those kind of things, we can't comprehend how the color, the shape, the time it happened, when it happened, who's looking at it, all these kind of things affect one result. That's when we use deep learning, because the computational resource is able to comprehend all of those things and still output a result. It's why we can give it pictures of multiple different cats, and it still figures out that if I give it a new picture of a cat, this is a cat, because it's thinking about not just one color in space. It's like the size, the shape. Does it have fur? Does it not have fur? Is it on the background of grass? Is it in a building site? Things like that. So deep learning is when we get more and more complex, and we give it more and more factors that influence the results. And that's where your LLM models live, because we're giving it more and more things to think about before it comes out with a result. I hope that explains it.
Thank you so much. Gonna move on to the next question. Is image data important, as not a lot of crimes are solved through CCTV, as it is a breach of privacy?
Oof, there's so many things going on there. Image data is important. Crime solving using CCTV, we have to think back to our data science model. Is the video surveillance footage that we have ready to be analyzed? A lot of the time, someone is too far away, we can't see their face, or we don't have the technological advances in that specific police station. They don't have the resources to analyze all of it. So whether it's used or not, it could be a problem of, is the data good? Is it a quality data that we can use to analyze that? Yeah, I think that's it. So it is important. You don't really hear too much about it, because I feel like right now we're sort of focusing on words and that. And I think because words is just it's a little bit easier. This is an industry secret. Words analysis is easier than image. We're still figuring that out. It's why when you create an AI image, she has 3 arms, and you never ask for that. So it's not less important. We're maybe less advanced in it, but it also means that in reality, people may not have access to the things that are able to analyze it that well for it to be used. So it may be a time thing, maybe soon.
On to the next question. How can data be programmed into a chatbot created by using AI?
How can data be programmed into a chatbot using AI? Okay, this is like a 6-week seminar question. Okay. So the way we do chatbots now is we give it the simplest way to create a chatbot is to take someone else's chatbot and then give it more data to be more specific to what you want it to chat about, and say only use this data. That's the simplest way to do it. If you want to take it a step back and build it yourself, that's a huge task in terms of giving it a language, for example. The way you program an English chatbot might be different to a French chatbot, for example. And we use data because the way AI and chatbots work is they see the words and the input you give it as numbers. And if it just says, okay, if I see the number sequence 111, usually what comes after it is 112. And 112 is correlated with the word, I don't know, honey. And 111 is correlated with the word bee. So it says, okay, so bees and honey. That's what it does. It doesn't see bee and honey. It sees 111 and 112. So you have to train it on lots of data to understand the relationships between the different numbers as it sees it before it now starts talking to you. And if you want it to be specific, you get more data on the topic you want it to increase its sort of outlook on something. Because remember, you can think of yourself, when you started with just your ABCs, you were great. And then we gave you more of the ABCs and you're like, okay, cool, I can create a word. And then we gave you more, and now you can understand sentences. And then more sentences meant you understood what sentences work better together, how to create complex sentences. It's the same thing, but instead of words with meaning, it's simply numbers kind of thing. So we start with numbers, we give it more and more data, and it gets more specific and specific and specific until we have what we end up with. Again, that's a topic for like 6 hours. That was condensed. So maybe one day I'll give like a seminar. Not today though.
Thank you for explaining such a complex question. Next question. What are some of the biggest challenges you have to face as a data engineer? And how do you overcome them?
All right. So one thing to clarify, data engineering is an actual role and title. That's what I need to clarify. And it means that you're maintaining, deploying, and creating the pipelines to which data can flow from different sources or from a source to another. And my role does that, but I also oversee the entirety of the AI sort of network and stuff like that. So as a data engineer, the biggest challenge is simply not having the right data. That is your biggest challenge. That is literally your job. Because when you're working at work, where else? When you're working, you have strict rules on security. For example, your company only paid for Excel. So therefore, if you get like a CSV, like a JSON file that Excel can't open, how do you transform it into a file that Excel can use without compromising it or losing a space, or if it's indented wrong or words go missing? Because these things happen. That's where a data engineer would come in, figure out how to transform that data and send it to your machine. Because it's not as simple as like an email. I wish it was, there's like AWS, there's cloud you have to think about in terms of how do I send it to the cloud network, and then the worker can access it from the cloud network, but not all workers because security issue and all that kind of thing. So the biggest one is just you have a data source and it's not ready to be used by the person who wants to use it. How do you transform it? And data comes in so many different forms and someone only just wants an Excel file. That it just becomes a big mess of things, and every day is pretty different. How do you deal with it? You have to just keep tinkering away. There's no real answer. You just keep clicking everything and hope one of them works. I'm joking. You do have processes that you're following. Sometimes you've seen this type of data before, so you know that it definitely needs transformation, but you're sitting there, your code is opened all the time. You're configuring authorizations, APIs, for example, and things like that. So it comes with the time. As you keep thinking, you keep like realizing what you can and can't do, but it's pretty much everything is so different that it's different every day.
Thank you so much. On to the next question. Where can we learn more about data science?
YouTube was my biggest teacher. There's so many levels of explanations on YouTube. So I'm trying to think of a YouTuber I know, but all of them are like master's levels because that's just the level I'm at now. But even like the Alan Turing Institute, they have programs for children. Teens in AI, if you do any of their boot camps or their events, they always have some sort of AI expert around that has given up the time to explain these things. So engaging with more teens in AI events, that's definitely important as well. Like I said, the Alan Turing Institute has programs for more like novice levels. But I think YouTube is the biggest one. Just type in data science for beginners and you will find lots of different content. If you're more advanced, the channel I love, I think it's called 3 Brown 1 Blue. It's a channel that just goes through different concepts and statistical concepts as well. So those kind of things. talking to more industry experts. If you're on LinkedIn, message someone, be like, hi, what's your job like? And I'm sure they'll understand. They'll like reply. People are pretty, like, they want to talk about their job on LinkedIn. So that's also another place you can look.
For someone aspiring to become a data scientist or engineer, what key skills should they focus on?
Key skills to focus on: coding. Pick a language, get good, and just get comfortable with it. You'll be doing more things with it than you think. So getting comfortable with where things are, how to download a package, how to read code, how to fix code. The language most used in the industry is Python, but in my job, I've used JSON. Is it JSON? Yeah, JavaScript, that's it. Sorry, it's because the extension is JSX. So I was thinking, wait, what's JSON? JavaScript, I've used Java, I've used HTML and CSS, so like the website languages as well. But if you've got Python, I believe you can learn the others, which is what you need. So Python there. Statistics, actually. Get your grips with like basic statistics, your mean, your mode, your max, your mins, like it will come up more than you think. And a few of like statistical models, like pick one. Like linear regression is the easiest to understand, so start there. What is linear regression? How does it work? You don't need to go into the maths of it. Ooh, I don't know about that, no. But you may need to go into what exactly is it telling me? What do the outputs mean? So that kind of thing. So the maths of data science is important. But apart from that, I think once you're coding, and also another spoiler, a lot of things come with the job, as in as you're given a problem, you'll figure out how to work with it. So if you're coding, you can then use your brain to figure out a solution and then code up the solution, which is what I would say.
What trends do you think will rise in the next 5 to 10 years in data science? What new technologies should data scientists keep an eye out for?
I don't know. Okay, I don't know. And I'm going to just share my thoughts because I think they are fast, but it's not that it was fast. It was more like we woke up one day and ChatGPT was everywhere, you know? So, and even though as a data scientist, I knew that it was cooking in the background for years, it was cooking, but we woke up and now the public are really into it and they're all using it. So it's hard to say what will have that kind of virality in later years. I would say if you want to be ahead of the curve, image work is still in its infancy days, that you can catch up and learn about it now. And if you keep up with it, you might be one of the first people to really be good at using or creating image understanding AI, that kind of thing. So that's something in its infancy that I think could get bigger, but we're just not there right now. Words are a big thing right now, and it's not going to go anywhere for some time. So understanding natural language processing, all that kind of thing, because that's what leads to your LLMs. But we're still trying to make LLMs better, so it's not like it's going to go anywhere. But we're trying to integrate more data forms into LLMs. So that's where you get your image processing, all that kind of thing. But image processing is not at its best right now. So you can jump on that and be early.
Thank you so much, Shanttel. I'm gonna close the Q&A session now. Thank you so much for being here with us today.
Thank you so much for having me.
I just wanted to thank again our corporate partners, Sage Foundation, and Red Hat for supporting our session today. Bootcamp week is not over yet. Thank you everyone who joined, and hopefully we'll see you again tomorrow.